To balance a chemical equation, you just need to follow this one basic rule, and that is you can only change the coefficient. And we remember that the coefficient is the number in front of a chemical formula. Now, what's so special about a coefficient? Well, when we change the coefficient, it multiplies. Remember, the coefficient multiply to all the subscript. So by changing the coefficient, you change the number of atoms for each element by multiplying it, okay? So that's the only rule that you really need to follow when we want a balanced chemical equation. But beside the rule, in addition to that one important rules, there are a little trick that you should pay attention to, and one of the most important one is that we always want to balance the elemental hydrogen or elemental oxygen last. That means we're going to save it last. And we are going to balance other elements first, especially metals. Okay, so let's do an example problem. The first thing we're going to do is, of course, we have to divide the reactant from the product side. And we are going to make this list. So we have calcium, hydrogen, and oxygen. See how I have calcium, hydrogen, oxygen. And then over here, of course, the list is going to be the same as well, because this is the same chemical reaction. And the next thing we're going to do, we have to count how many do we have, with the assumption that all the coefficient is going to be 1. Okay, so every coefficient now is going to be 1. If that's the case, how many calcium are we going to have? Of course, we just have 1, because 1 times 1 is 1. What about for hydrogen? Well, hydrogen here, 2 times 1 give us 2. Then we have oxygen, which is 1. 1 times 1 give us 1. Now on this product side, we have calcium. Look at this 2 right here. This 2 is only applied for whatever inside the parentheses, okay? So we have calcium, we just have 1. And then for oxygen, look at this 2 times 1 give you 2. But for hydrogen right here, right, 2 times 1 give you 2. But we also have another 2 right here. So that gives us a total of 4. And that's how we count the number of atoms for each element. So to balance this, remember the golden rule is that you can only change the coefficient. And the strategy is always save the elemental hydrogen and oxygen last. Do we have any of them? Well, in this case, we have the elemental hydrogen. We're going to save this last, okay? So let's go and balance other thing. In this case, the calcium is already balanced. And we look at the hydrogen. Here we have 4, and here we have 2. So where do we have hydrogen on this side so that we can multiply and change the coefficient to give us 4? Here we have the hydrogen right here, okay? So we're going to ask ourselves, we want a total 4, isn't it? Because this product side gives us 4. So we have 2 times what number will give me 4? And that number turned out to be 2. And notice how I just get rid of the coefficient 1, because we are now replacing with 2. So if that's the case, we have 2 times 2 give us 4. And then we have 2 times 1 give us 2. And look what happened. The calcium balance, the hydrogen balance, as well as the oxygen. So let's try another one. The same thing, right? We assume all the coefficient is 1. And we are going to make a list between the reactant and the product. In this case, we have Ba, hydrogen, and oxygen. And over here, we will have the same list as well. Ba, hydrogen, and oxygen. And how many Ba do we have? Or barium, we just have 1. For hydrogen, 2 times 1 give us 2. For oxygen, 1 times 1 give us 1. And then over here, Ba, again, this 2 only applies to what's inside the parentheses. So in this case, we have just 1 barium. And then for hydrogen, we have 2 times 1 give us 2. We also have 2 right here that give us 4. And then for oxygen, we have 2 times 1 give us 2. Now the next thing again, we want to save the elemental hydrogen and oxygen last. In this case, this is the one right here. we are not going to touch this coefficient. So let's get to the hydrogen. So what we have here is 4 hydrogen. Oh, look, very similar problem right here, right? So in this case, we have 4 hydrogen, we have 2, and this is the only place that has hydrogen. So we're going to ask ourselves 2 times what number will give us 4? 4 is coming from here. 2 is coming from here. And this box is coming from here. In this case, the answer is 2, because 2 times 2 gives us 4. So therefore, we're going to replace this by 2. So if that's the case, so now this 2 times 2 gives us 4, and 2 times 1 gives us 2. And it is balanced. And that's how you balance a chemical equation. Very easy, isn't it? Let's try a harder problem. In this case, again, the same thing, we assume the coefficient is going to be 1 for each one of them, and we are going to divide the reactant from the product side. In this case, we have K potassium, H, O from this side, right? And of course, this side is going to be the same, KHO. Now, how many K do we have? Well, in this case, 1 times 1 is 1. And for hydrogen, 2 times 1 is 2. And for oxygen is just 1. And over here, we have K. That's just 1. There's no K here. For H, here we have, look at this. We have 1 H here, and we have 2 H there. That gives us a total of 3 H, right? And over here, we have O, just 1. So what we have here is everything is balanced except for the hydrogen, which is the elemental one, right? This is the last one that we want to focus, and it turned out to be the last one. Here's the tricky part. Notice this is an odd number, and this is an even number. It's almost impossible to multiply the same number, make an even and odd be the same number. It's impossible. It will never be equal to each other. In this case, what we have to do is we have to increase this by 1 more. What's after 3? Well, we have 3. What's the next number? 4. So can we manipulate this? Well, in this case, see how this is an even number? So if we multiply by another one, this continues to be odd number. Because this little one right here is the odd part. So what can we do? What's after 1? We can make it 2. So how do we do that? So we're going to ask ourselves, 1 times what number will give me 2? Because I want to make this into 2, and 2 plus 2 give you 4, give you an even number. So in this case, what's 1 times what? Give you 2. So the answer is 2. So this now becomes 2. So again, think of balanced chemical equation like a puzzle. We continue to test it out to see if it's actually worked. Let's test this out. So if that's the case, now we're going to have 2 times 1 give us 2K. Well, look, it messed up the whole entire problem, but let's continue. So 2 times 1 give us 2 oxygen as well. But what about hydrogen? 2 times 1 give us 2 plus another 2 over here. So what is 2 plus 2? And that gave us a total of 4. So now we have even number, but over here we have an odd number. But let's see how this is going to work. We are going to balance a K because again, we're going to save this last, right? So K, I have 2 over here. So you can ask yourself, 1 times what will give me 2? So 1 times what number will give me 2? Of course, it's going to be 2. So now, oh, that's pretty easy. Okay, so the K is balanced. And the only thing not balanced is the H and O. And of course, we are going to save the H last. Because over here, what we have here is 1 O and 2 O. So we go up here, find where we have oxygen. Here we have oxygen, here 1. So we're going to ask ourselves, 1 times what number? Notice how I say what number. I assume even the coefficients there, I assume we are going to change to a different number. So keep that in mind. So 1 times what number will give me 2? In this case, 1 times 2. So this will be replaced with 2. In this case, we have 2 oxygen, but what is 2 times 2? Turned out to be 4. Now we have a balanced chemical equation.